Okay, so here we are, VCAA 2021 Maths Method second exam, section B, question 5, which is the last question on this paper. So what have we got? Part of the graph of f r into r, fx equals sine x on 2 plus cos of 2x is shown below. There it is. State the period of f. All right, so the period, of course, is where it starts to repeat itself again. So, let's just take this peak here, just close to 0. And when we get back, after we've done all the possible wiggles, we get that to that peak here, but we haven't done this part of the thing. So it's not till we get back to here. And so you can look at that from down here, if you like. All right, that there. That there, and then once we get to here, off we go again. So what's the distance between here and here? By the looks of that, 4 pi, so period of 4 pi. All right, state the minimum value of f correct to 3 decimal places. So you need to use your calculator for this. All right, so you need to get your calculator and then switch it on. And here we go. Right, there it is. Let's get to some graphs and tables. Let's get rid of those. Okay. All right. So we've got to put in our function that we got, sine x on 2, sine x on 2, what is it, plus cos 2x, plus cos 2x, oops, wrong bracket. All right, so there we go. That's what we're going to graph, so let's graph it. And when we do, we get something that looks like what we've got. And we want to know the minimum values. So we go analysis, G-solve minimum. And it's going to give us the minimum value. And there we go, there's minimum value. It's marked 1 of them. And it's at the radian negative 4.6, but we're after this part here, negative 1.722, and then some stuff. But this one we've asked to do to 3.3 decimal places, so the minimum value is negative 1.722. All right. Find the smallest possible value of h for which f of h minus x is the same as f of x. All right, so we've got a reflection here, and then we've got a translation. So a reflection, that means we're reflecting this stuff over to there, and vice versa, or this stuff over to there. So this peak reflects to there, and then we've got to move it to be on the same as there. So taking this peak, go on a reflection over to here, and then we've got to move it back to there. And so I've got to move it from negative pi to pi, so I've got to move it to pi. So h, which is our, this one here, which is our translation, would be 2 pi. All right, so there's that part done. Now the next part here, we come up and we now consider the set of functions GA, where GA is sine x on a plus cos ax, where a is a positive integer. So the value of a such that GA is equal to fx. So now let's go and compare the equations, and when you do compare the equations, you see that they're the same form, sine x on something, cos something, and these two somethings are the same. In this case, they're both 2's. So when you compare that to here, a on a, x on a, ax, those numbers are the same. In fx, that was 2. So all you need to do is compare those equations, and so a is 2. All right, find an antiderivative of GA in terms of A. So we want an antiderivative of this thing. So you can get your calculator to do that, or you can remember the pattern and sine antiderivative. Sine comes from cos, so there's got to be a negative there. Cos x on A. And of course the constant is 1 on A, so 1 on A is A, and plus, if you differentiate sine AX, you get cos, and of course we need the constant. So there is an antiderivative of GA in terms of A. All right, so next, use a definite integral to show that the area bounded by GA and the x-axis over the interval 0 to 2a pi is equal above and below the axis for all values of A. All right, so we need to show, so there's got to be some working out going on. It says to use a definite integral, so that's what we need to write. We need to write a definite integral. And so that definite integral is between 0 and 2a pi. There it is. All right, of what? Of GA. Now, GA, of course, is sine x on A plus cos AX dx. And now we need to antidifferentiate that. And we found antiderivative up here in part 1. So we're going negative A cos x on A plus sine AX all on A between 0 and 2a pi. All right, so let's expand that. Now remember, it's 3 marks here and we're asked to show, so we need to do working out. All right, so then the next step down is to substitute negative a cos 2a pi on A plus sine 2a pi times that a there, so it's 2a squared pi all over a. And then from that we're going to subtract x equals 0. So we're going to subtract minus a cos 0 on a plus sine 0 over a. All right, so the a's cancel there, and so we want cos of 2 pi, and cos of 2 pi is 1. So we've got negative a there. All right, this bit here, remember a is, up here, a is, whoops, a positive integer. So a is a positive integer, then we're going to square it, and so we're getting some other integer, and then we're multiplying it by 2. So effectively what we've got here is a multiple of 2 pi. So a multiple of 2 pi always brings us back to that, around the circle, back to that same spot where sine is, for 2 pi, sine is 0. So if we ended up at a multiple of 2 pi, so it's a multiple, we then end up with 0 for that bit. So 0 on A minus, okay, here we go, cos of 0 is 1, so negative A here, and then sine of 0, of course, is 0, 0 on A. All right, so what do we got here? We've got just negative A there. We've got negative A minus A. Of course, that's a positive. And we could put that. So we've got negative A plus A. Should have some equals there. Make that a bit better. Equals to 0. All right, for that integral. So if we've now got that integral equaling 0, so therefore areas above and below the axis, or the x-axis, are equal. For all values can't spell of A. All right, because we haven't taken the A out. All right. So that's shown what we've been asked to show there for that one. All right, so we then got one last part of the, or no, two more parts of this question. All right, let's have a look. All right, explain why the minimum value of GA cannot be greater than 2 for all values of A. Why the minimum value of GA cannot be less than. All right, so let's look at each of the two bits and their ranges. All right, because that's what we're talking about, minimum values, maximum values. We're talking about the ranges. So the ranges. Now, the range for sine x on A has got to be the same as sine of anything. It's got to be between -1 and 1. All right, can't be whatever that is. You can't get anything smaller than -1. You can't get anything bigger than 1. And for the cos AX, it's a similar argument. Whatever that angle there is, when you take the cos of it, you can't get anything smaller than -1, and you can't get anything bigger than 1. So our range of GA then must be between, because GA is the combination, that plus that, we can't get anything smaller than adding together the -1s, so -2, or bigger than adding those two. All right, because GA, as we've said, GA is the sine plus the cos. All right, so each of those ranges, add them together, you get that one there. All right, so explain why. I guess that's what you need to write down there in some form or another. I didn't find the examiner's report myself overly helpful with what you actually need to write to explain, but when I've explained that in words. All right, so find the greatest possible minimum value of GA, the greatest possible minimum value. Now, what you need to do with that for the greatest possible minimum value is you need to, well, the best way of doing it would be going to your calculator, which I'll show you here. Get rid of that rubbish. All right, and what you need to do is on your calculator, you need to graph a few things. So this is when one we've done is when A is 2. What you need to do is try different values. So this one I'm now doing is, whoops, this one I'm now looking at when I get there is when A is 1, and graph that one when A is 1, and there we are, we've got that, and then we go analysis, G solve, find our minimum, and it will give us the minimum. There it is, negative 1.414. And so when you do that, and then A is 2, then you do it for A is 3, and when you do that on your calculator, you find the following. So when A is equal to 1, so G of 1 is sine x plus cos x, and you find your minimum is negative 1.414, and when A is 2, so G of 2 would be sine x on 2 plus cos 2x, and the minimum of that is, we did that one before, this is negative 1.722. And then if you go again, A is 3, all right, because I've prepared one earlier, x on 3 plus cos 3x, and the minimum of that is negative 6.464, well, 1.646, and you can continue doing that if you like. A of 4, G of 4, sine x on 4, right? It's pretty easy to just in your calculator just to change those numbers, and then you get negative 1.981. All right, so question says, what is the greatest possible minimum value of GA? So these are the minimum values, the greatest. All right, so remember we're going into negatives here. So the greatest would be the one that's highest up the graph, and the one that's highest up the graph in the y direction is this top one here, which is negative 1.414. Now, the calculator gave me a decimal answer, doesn't ask here for a decimal answer. However, 1.414 is the square root of 2. So our greatest possible minimum of GA is equal to, well, it's a negative number, and it's negative root 2. All right, so what I've done to do it, basically I've graphed all of those things. I've looked at the minimums, I've now looked at the trend, and I'm seeing that the one that's going to be highest up is this one. What is that in? And I just happen to know that the square root of 2 is 1.414, and so then I write it as an exact value. All right, so that brings us to the end of question 5. It also brings us to the end of this particular exam. And of course, don't forget, get your teacher's opinion on things. Also look at examiners' reports and see what they've got as well.